Welcome back. Now we're gonna be talking about the mole concept. If you recall, the mole is an amount of a substance which contain how many particles? 6.02 times 10 to the power of 23 particles, and these could be electrons, ions, atoms, or molecules. Okay? This number is also known as Avogadro's constant. Good job. So now we have the relative atomic mass, which is the sum of the relative atomic masses of each atom within the molecule. So for carbon dioxide, we have the mass of carbon, which is 12, and there's only one atom of carbon, so you multiply that by 1. Okay, and then you have the number of atoms of oxygen, which is 2, and you're going to multiply that by the mass of oxygen, which is 16. And then what you're going to do is you're going to add the two products, and that's going to give you your RAM, your relative molecular mass, which is 44. That's it. So now we're going to figure out what the mass of ammonia is. So for the mass of ammonia, we're going to get the mass of nitrogen, and if we look at the periodic table, nitrogen is right over here, and the mass of nitrogen is 14. Remember, the mass number is the top number. So I'm going to say 14 multiplied by the number of atom of nitrogen, which is 1, multiplied by 1, that gives me 14 grams. Next, I'm going to move on. I'm going to do the same for hydrogen. So the mass is always at the top number. So the mass is 1 for hydrogen, but there is how many atoms of hydrogen? There are 3 atoms of hydrogen, so I have to multiply that by 3. Alright, and that's going to give me 3. And then what I'm going to do is I'm going to get the sum of these two products. So 14 plus 3 is going to give me 17, and that's my relative molecular mass.